Hello, everybody. My name is Jose Iniguez. I'm a landscape ecologist with the Rocky Mountain Research Station. And I'm here to present a study that was actually done by Megan Singleton, who was a student at NEU at the time. I was in the graduate committee. She's now taking another job, bigger and better money. And so, but I wanted to kind of make you aware of this study. I'm not going to go through the whole study, but just kind of give you a taste of it. Hopefully, it's already published. It's in Landscape Ecologist. Hopefully, you go out and read it. So again, I'm with the Forest Service. The other colleagues in this particular study were with the Northern Arizona University, and or Jen Stevens is now with the Forest Service, was with USGS at the time. So anyway, kind of this idea of what's going on with landscape high severity patches in the Southwest is the main theme of this study. So before we get into that, though, I think it's important to acknowledge the role of fire in the Southwest. And fire has always been in the Southwest and has always been part of the forested systems in the Southwest. We know this because of the many fire history studies that have been done. And I think it's always had a role in the Southwest, and I think it'll always continue to have a role in the Southwest. So no matter what, fire is with us has been with us and will continue to be with us. And I think it's important to acknowledge that. Of course, the many fire history studies have documented a frequent fire regimes, particularly in ponderosa pine systems and mixed conifer systems, and then a suppression of fire after 1900. And in the last, since 1900 to about 1990, fire suppression was really good at excluding fire from many of these forested systems in the Southwest. But then in 1996 and the late 80s, I guess, 1990s, started to be more and more fire across the Southwest, and that has continued to increase, kind of punctuated by two main fire years, the 2002 fire year and the 2011 fire year in the Southwest, which is kind of like the dominant fire years that created a lot of the high severity patches that we see on the landscapes across the Southwest. In terms of the consequences of fire exclusion, I think the main one is an increase in tree density. That is, those historical fires before 1900 were really good at kind of taking out those really small trees. And so the lack of fire has allowed those trees to mature. And so now they've increased the surface, the surface fuels and the canopy fuels, making these areas more vulnerable to stand replacing fires, which we have seen and has been documented in the last 30 years. Particularly Megan Singleton, the author of this particular study, she actually did her master's too at NEU in another project of ours. And she actually documented an increase not only in the size of fires in the last 30 years, but in the severity of the fires, and more importantly, in the percent of the high severity of those fires. So fires are getting hotter and they're getting larger in the last 30 years, which is important. We kind of all knew that, but I think it's important to quantify it and to see how we're going to deal with this in the future. And of course, these fires are resulting in a number of high severity patches. And so the main question here is the characteristics of the high severity patches, because that information is actually very important when you're talking about land management, right? In terms of vegetation, how that vegetation is going to recover, the structure of that patch is going to be very important. How much core area there is, how much edge there is going to affect the vegetation recovery, the amount of water in that area, and how that water runs off. So it's going to affect flooding and downstream communities from those fires. It's also going to affect wildlife habitat, especially species that like some of these denser forests, like spotted owls, right? And it's ultimately it's actually goes to the fundamentals of land management, right? The land management, the idea of land management is to preserve and create sustainable ecosystems. And this is actually threatening that sustainability. That is, some of these systems and these patches are creating areas that might not be able to recover because the seed source might not be suitable to get to these areas. So they might actually be converting some of these forests to non-forested systems. So it's very important to understand the structure of these high severity patches. And it's also important to understand how to avoid these high severity patches. And I think that one of the main things that we can do is allow more managed fire. The idea of managed fire is to allow fire to play its natural role, natural ignitions to play a natural role in forested systems. This is nothing new. Managed fire has been around in different iterations in wildfire use since the 1960s in the park, 1970s in the Forest Service. But in 2009, there was a new policy guidance that allowed managers a greater flexibility to apply managed fires in the Western U.S. And we've actually documented some of these changes in a paper by Jesse et al. In 2020, where we actually documented by region. And so there is more managed fire. In some places, there's more fires themselves and more area being burned by these fires. In some areas, it's actually just more incidents that are being managed, not necessarily increasing the total area. But there is some change in terms of how we manage fire and what we do with these managed fires. So it's important to know what the effect of these managed fires is compared to the classical fire suppression strategies. So with that, the objectives of this particular study were to determine how the difference in terms of high severity patch structure between managed and suppression fires. That was kind of the first basic questions. We also wanted to understand how fire size and proportion or percent high severity influence the structure of these high severity patches. And lastly, we actually looked at these high severity patches over time, so the temporal component. But given the time limit for this particular study, I'm not going to actually delve into that, but that is actually covered in the paper. So if you want more detail, you can read that information in the published manuscript, published paper. So kind of getting into the methods here. For this particular study, the study area is the southwestern U.S., so that states of Arizona and New Mexico. And even within those two states, we were actually only looking at high severity patches that were within forested or woodland ecosystems. And to this, we used the Wilbur 2014 paper, which actually has a map product that covers it's a wall-to-wall product for the southwestern U.S. that is used by the Forest Service. And so this wall-to-wall product covered our area, and so that's how we delimited the areas that we were interested in the forest and woodlands. And we used the MTBS perimeters to determine where the fires were. So this includes only fires that were greater than 1,000 acres or 404 hectares. But we actually didn't use the MTBS severity. We actually calculated our own severity using Google Earth Engine and some of the algorithms provided by Sean Parks and some of his revisions of that paper. So the latest and greatest on that one. And to determine the high severity for this particular study, we actually used ground plots, which were CBI plots, and calibrated those to determine the high severity pixels that were only greater than 687 relatively burn index. So an RDNBR of greater than 687 was how we classified high severity pixels, and then we aggregated those pixels into patches for this particular study. And so again, the more details are that provided in the paper. And we also had to classify, of course, the actual fires themselves into suppression or managed fires. And to do that, we actually used the data from the Jesse Young et al. Paper, the 2020 paper, where we used the 209 reports for each individual fire and to classify to distinguish between managed and surface and suppression fires. And we also, for some of the other fires, a minority of the fires, we actually used the MTBS information on the MTBS for individual fires, whether they were wildland fire use, prescribed fires. We included those as managed fires, or research objectives fires that were identified in MTBS. There was a few fires, 46 of them, that we could not identify, but the whole data set included 709 larger fires. And so how do we define, how do we characterize these high severity patches? We use kind of 5 traditional landscape metrics using, Megan went through great details to kind of find the 5 best ones. And those are the top 5 here. And then we also used the standard placing decay coefficient, which is a metric that was kind of pioneered by Jess in California, by one of the other co-authors. So, but Jen Stevens. So I think so we use 6, and the first one is class area, right? So the total amount of high severity area within a fire. The second one is a reach landscape metrics, and it's the gyration radius. So it's kind of the distance kind of to the edge of the patch. So that's measured in meters. And then the other one we use is total core area. And for core area, we define core area as the area with that is within the patch that is further than 200 meters from the edge. And then the other one we use is the perimeter to area ratio, which kind of characterizes the complexity of the patch. And then we also use percent of like adjacency to describe the aggregation of the particular patches. So for each of these patches, we apply them to each of the fires, and then looked across the different classes. So the first one, first kind of comparison we did is comparing suppression fires to managed fires. And what we found is that suppression fires in general have more high severity areas than managed fires. And so for all the 6 metrics that we looked at, all of them were significantly different between managed and suppression fires. So suppression fires had larger high severity patches. They had more core area. And so those patches were not only more of them, but they were actually larger. So that it was a greater distance to get to the edge of those patches in suppression fires compared to managed fires. Because of the patches in suppression fires were also more complex, meaning they had a greater edge, that resulted in a smaller value of the perimeter to area ratio. And so that one was also different between suppression and managed fires. So again, all of them showed a significant difference between some managed and suppression fires, which was as expected, and something we kind of thought it was right, but I think this is important to quantify that relationship. In terms of how the patch structure relates to fire size was also very interesting. So as the fire sizes, the size of the fires get bigger, we tend to see more high severity area, and that relationship is actually significant for all the metrics again. So and that is regardless of whether the fire is managed or suppression. As the fire gets bigger, we tend to see more high severity area and more total core area within those fires. We also tend to see greater distance to the edge, so the patch reach is actually larger as the fires get larger. Similarly, well, as the fire gets larger, the amount of edge in those patches gets greater, and so the perimeter to area ratio gets smaller. And again, you can kind of see the other results. And so here, the red dots are suppression fires, the blue dots are managed fires, but the relationship actually holds for both of these. That as the fire size gets bigger, the patch kind of behavior is common between managed and suppression fires, which I thought was kind of interesting. When we look at the percent high severity and how that changes with how that affects the patch structure, again, as the percent high severity increases, we tend to see more high severity area and more total core area of high severity. And the patch reach again becomes larger. So there's a greater distance from the to the edge of these high severity patches. And again, the perimeter to area ratio decreases as percent high severity increases. So similarly, so the relationship is somewhat similar to the relationship that we saw with fire size. That is, as far as the fires in the percent high severity get increased, these landscape metrics tend to behave similarly, whether the fire is managed or suppression. So it's more related to fire size and percent high severity for these cases. In terms of what do these results mean? I think the important thing here is that I think it's important that we acknowledge that it's important how we manage these fires. Yes, managed fires are definitely fires that happen in the shoulder season. That is, that they happen in the spring or in the fall, whereas suppression fires tend to occur in the peak of the fire season and in the worst of conditions. So yes, the suppression fires tend to lead to larger fires, and so the landscape metrics tend to change accordingly. And we also kind of tend to see, we also found larger patches in particular concerning was in Ponderosa Pine, where the highest, the largest patches historically that were found in Ponderosa Pine were maybe 100 hectares, whereas now we're seeing in thousands of hectares, which is important. But we didn't actually break it down by vegetation type, but that's something that we're thinking about doing in the future. In terms of fire size, I think it was really important that as far as fires get larger and the percent high severity gets greater, we tend to see a homogeneous, more homogeneous patches in regardless of management strategy. And fire size and percent high severity is actually related to climate or vapor pressure deficit. And so vapor pressure deficit is actually then related to patch structure. So I think it's important when we're managing these fires and how we're managing these fires in terms of what the consequences are of these high severity patches. And in conclusion, I think that climate is really what's dictating, you know, these high fire, these large fire years, 2002, 2011. And so those large fire years are when we see a lot of the high severity patches. And so it's important that we treat these landscapes, as many of these landscapes as we can, and prepare to get prepared for those big, large fire years. And we get those treatments down in the ground as soon as possible. And yes, we can do mechanical treatment, but I think that the best way to go is to use this idea of managed fires, to manage fires during their shoulder season, to get a minimal, the more desired effects, and to create more sustainable landscapes and more conditions they're going to be able to withstand the climate change that are coming upon us. And with that, I thank you for your time. Thank you. Bye.